Alright, here's our continuation of 2.4 where we're talking about the chain rule. In our last video we talked about theorems 2.10 and 2.11 as well as looked through examples 1 through 3, and we're going to pick up on example 4 here. We're going to have the function g of t is equal to negative 7 over the quantity 2t minus 3 squared. Now this can be rewritten as negative 7 times the quantity 2t minus 3 to the power of negative 2. Now what I'm going to do, and I've said this in our last video, anything I have in parentheses, that's what I'm going to let u equal. So u is going to be 2t minus 3, so u prime will just be 2. Excuse me. And then I'm going to let g of t equal negative 7 u to the negative 2, which means in this case our starting to g prime is going to be 14u to the negative 3. If I bring negative 2 down and I multiply that by negative 7, that's where I get the 14, and I reduce negative 2 by 1 to get the negative 3. So g prime of t is going to be what our g prime over on the right side is, 14u to the negative 3, times our u prime, which is 2, which means this is the same as 28u to the negative 3. I'm going to take care of this negative exponent quick, so I'm going to rewrite this as 28 over u cubed, and then I'm going to replace the u with what we let u equal. So this is going to be 28 over quantity 2t minus 3 cubed. And then we're done finding that derivative. So let's look at example 5, which I think so far in this lesson, example 5 will be maybe one of the harder examples. Still not impossible, just a little bit more difficult. We're going to say our function f of x is equal to x squared times the square root of 1 minus x squared, which is the same thing as x squared times 1 minus x squared to the 1/2. So before I even move on and I let u equal things and whatnot, I'm going to notice that I technically have a product going on here. So to review the product rule from our last lesson, it is the derivative of the first, not the derivative of the first, excuse me, it's the first times the derivative of the second plus the second times the derivative of the first. So f prime, and I'm going to start using a notation in this example that I haven't been using. I'm going to take x squared, that's my first part, and then I'm going to multiply it by the derivative of our second term, 1 minus x squared to the 1/2, plus I'm going to take the second term, 1 minus x squared to the 1/2, times the derivative of our second term, now that d dx just means I need to find the derivative of what I have in the parentheses with it. So I need to find, when I'm finding this complete derivative, I can just rewrite my x squared that I wrote first. But the derivative of the things in that parentheses, I'm going to be utilizing the chain rule for. So what I'm going to do is I'm going to bring down my 1/2. 1 minus x squared to the negative 1/2. And really the chain rule then just says I'm going to take the derivative of the stuff on the inside. So the derivative of my stuff on the inside is going to be a negative 2x. Plus, okay, I'm going to rewrite 1 minus x squared to the 1/2. The derivative of what I have in the parentheses there is going to be 2x. Now, I'm going to look at the two terms. In fact, before I continue, I'm going to clean up what's in this first grouping of parentheses. I do know that this 2 and this 2 cancel each other out, so we're going to have an x. In fact, let's just distribute that x squared in there. We're going to have a negative x cubed times 1 minus x squared to the negative 1/2 plus 2x times 1 minus x squared to the positive 1/2. Now, the two sides of the plus sign have some things in common. They both have an x, so let's start by factoring an x out. I also see that they both have parentheses with the same things in it. I'm going to factor that out with the lowest power, and our lowest power of 1 minus x squared is a negative 1/2, which means inside, from what I originally had, what's left over is going to be a negative x squared times 1, because 1 minus x squared to the negative 1/2 divided by itself is 1, plus 2 times 1 minus x squared to the power of 1. I don't really need to write the 1. Now, I'm going to move on to another page, but I'm going to rewrite what I have here at the bottom. Okay, so I'm going to take care of my negative exponent quick before I do anything else. So I'm going to rewrite my derivative as x times negative x squared times 1 is just negative x squared, plus, and I'm even going to distribute this too, so plus 2 minus 2x squared over the square root of 1 minus x squared. So I'm almost done. I can combine some stuff up in my numerator, so I can have x times negative 3x squared plus 2 all over the square root of 1 minus x squared. And then I'm going to distribute my x. I'm going to end up with negative 3x cubed plus 2x over the square root of 1 minus x squared for my final answer. And I told you at the beginning of this example, this one, from what we've already been doing, was so far our most difficult example. So let's look at another one that might also be a little difficult. We're going to look at example 6. We're going to have y is equal to x over the cube root of x squared plus 4. So we can rewrite this as x over x squared plus 4 to the 1/3. Now, we could bring what we have in our denominator up and use the product rule like we did in our last example. I would like us to, just for the sake of reviewing the quotient rule, keep it the way it is and use the quotient rule, which, as a reminder, is we take our denominator times the derivative of our numerator minus our numerator times the derivative of the denominator over the denominator squared. You don't have to write that part down because it should already be in your notebooks. Now if we're looking at all this, our g would be our x squared plus 4 to the 1/3, and our f would be our x. So let's do this. Let's find our derivative. So y prime is going to be g, which is x squared plus 4 to the 1/3 times f prime, which the derivative of x is just 1, minus f, which is going to be x, times the derivative of g. So that's going to be 1/3 times x squared plus 4 to the negative 2/3 times, we have to use the chain rule when we're taking the derivative of g, 2x. And then remember we're using the quotient rule, so that all has to be over g squared. So we can actually just rewrite g as x squared plus 4. If we square all of that, our power is really just going to change to be 2/3. So let's keep it going. I'm going to clean up what I've got in my numerator. So I'm going to rewrite x squared plus 4 to the 1/3. And if I multiply it by 1, I can actually just get rid of the 1. Minus, in that next term, I can multiply my x, my 1/3, and my 2x. So I can have 2x squared over 3 times x squared plus 4 to the negative 2/3. And then that's all over x squared plus 4 to the 2/3. And now up on top, in fact, not just on top, but yeah, just in our numerator, I notice both terms have something in common. They both have an x squared plus 4 to some power, so we're going to take that least power, 2/3, out. And I'm also going to try to get rid of that fraction, so I'm going to bring out a 1/3 as well. So I'm going to be left with inside, if I'm taking a 3 out, that means I have to multiply take out a third. I have to multiply everything in the original numerator by 3. So I'm going to have 3 times x squared plus 4 minus 2x squared, and then put all of that over x squared plus 4 to the 2/3. Now, I've run out of room on this screen, so I'm just going to make another screen, and I'm going to copy down what I just wrote. Alright, so I'm going to do a couple things. I am going to bring my negative exponent down. So I'm going to have in my numerator just the 3x squared plus 4 minus 2x squared. So I might as well just distribute while I'm at it. So I'm going to have 3x squared plus 12 minus 2x squared. And in the denominator, I'm going to have 3 times x squared plus 4 to the 2/3 times x squared plus 4 to the 2/3. And in my denominator, I've got two bases with an exponent raised to a power. I can just add them. So in the denominator, I'm going to end up with 3 times x squared plus 4 to the 4/3. And in the numerator, if I combine like terms, I'm going to end up with an x squared plus 12. And there's nothing else I can do, so my derivative is done. We've got enough time that I think we can do one more example in this video. Example 7, our function is going to be y equals 3x minus 1 over x squared plus 3, and that whole thing is going to be squared. So, when we're finding y prime, we're going to start by bringing 2 down and have 3x minus 1 over x squared plus 3, but we need to find the derivative of what we have here in parentheses. So, utilizing the quotient rule, we're going to write our denominator, x squared plus 3, times the derivative of the numerator, which will just be 3, minus the numerator, 3x minus 1, times the derivative of that denominator, 2x, all over that denominator squared. Now, let's clean all that up. Let's just focus on that big set of parentheses first. So we'll bring our 3x minus 1 over x squared plus 3 through. I'm going to distribute this 3 and this 2x, and then I'm going to distribute the minus after that. So I'm going to have 3x squared plus 9 minus 6x squared minus 2x, which if I distribute the negative that's in front of that, I'm really just changing signs then. So I'm going to ditch off my parentheses and change the minus between the 6x squared and the 2x to a plus. And that's all over x squared plus 3 squared. Now we can combine stuff in our numerator, and I think I might have enough room to do this before I need to move on to another page. So we're going to have 2 times 3x minus 1 over x squared plus 3 times 3x squared minus 6x squared, negative 3x squared, plus 2x plus 9, all over x squared plus 3 squared. I'm going to rewrite that at the top of the page on another one, so give me a second. Alright, so now let's multiply. We'll multiply our 2 by our numerators, so we're going to have 2 times 3x minus 1 times negative 3x squared plus 2x plus 9 all over, we'll multiply our denominators, and x squared plus 3 is part of both of them. So let's just rewrite this as x squared plus 3 cubed. Now you could keep going and distribute your 2 and FOIL some stuff, but I'm lazy and I say this is a good enough spot to end this example, which this derivative looks pretty complicated, but we did it. We made it through, and we're going to wrap up this video, and we'll finish 2-4 hopefully in our next video.